Okay, why Erlang? Why is it that we're putting together a course about Erlang, and why are you following the course? I think in order to understand why Erlang is so special, we should go back to the late 1980s and to the computer science lab that was run by Ericsson in Stockholm. And there, a number of researchers, including Joe Armstrong, Mike Williams and Robert Verding, were looking at trying to find the right language for programming telecom systems. And they tried a whole slew of languages. There were functional languages around, procedural languages, all sorts of things. And what the conclusion they came to was that none of them was completely satisfactory for what they were looking for. And it's worth just going over what they were looking for. They were wanting to build complex combinations of hardware and software that constituted telecom switches and things like that. So what they were doing were building systems that existed in a highly concurrent environment. Hundreds, thousands, tens of thousands, hundreds of thousands of calls might be handled simultaneously by one of these boxes. So they wanted to be able to deal with concurrency. And if they were looking at concurrency, it wasn't enough to look at what was provided by operating systems threads. They needed something much more lightweight and something where they could spawn tens, hundreds of thousands of those threads quite happily. So they needed lightweight, fine-grained concurrency. Also, it's important to realise these are systems that are an amalgam of hardware and software. So what they had to do was be tolerant of failure. And this is real hard failure of hardware components. This is not some software raising an exception. This is hard failure. And so they needed to build in some sort of rationale for handling failure. And to do this, what they did was adopt the let it fail philosophy. You can't prevent a piece of hardware failing, so why not let that philosophy of not expecting components to deal with their own failure, but building systems which handle component failure, why not let that philosophy pervade the design of the language and the design of systems in the language? And so they did that. So they built a language with lightweight processes, with ideas of supervision. So instead of a process dealing with its own failure, another process, another component of the system would deal with that separately. Also, what they were keen to do was build systems that would be up all the time. You can't take a telecom switch down to install some new software. You have to be able to upgrade the code while the system is running. And so hot code upgrade, giving them something like 9 nines availability in the best cases, but in practical cases, something like 6 nines availability. That's 99.9999% availability. And they built into the language, right at the heart of the language, a mechanism for swapping in a new piece of code for a running program. And that could be a program that's in a loop. You could swap in a new piece of code for that very tight loop that was running. So they wanted all these features, and the question was, what was the best basis on which to build those features? And the answer was a functional programming basis. So functional programming is the substrate on which this fine-grained concurrency, this let-it-fail philosophy is built. Because functional programming is that much simpler. You don't have a state that is updated, you simply have values that are computed. And this allowed the very elegant design that we see in Erlang as it exists. So what we're doing in this MOOC, in fact, is concentrating on the functional programming part, and once we go to the final version of the MOOC, we'll also, of course, study the concurrency and other aspects. So since the late 1980s, other things have been added to Erlang. In particular, the Otp layer, the Open Telecom platform, has been added. What that does is use the functional programming constructs and as well as the concurrency and so on, to build generic components for things like a server, a finite state machine and so on, so that each time a programmer sits down, they don't have to think about the failure aspect of a server. That's all there. All they have to think about is the particular design of the server functionality. And that, that abstraction really pays huge dividends in practice. Erlang is now an open source system. It's available on GitHub and there are a number of contributors to it, even though Ericsson still provide a heck of a lot of support through the OTP team. So it's managed by the OTP team, but open source contributions are coming in larger and larger numbers. It's used across the field. It's used in areas like online betting, like Paddy Power, systems which are message intensive, like Grindr, and of course the big news recently in the last year or so has been the acquisition of WhatsApp for some $18 billion. And at the heart of WhatsApp are servers that run in Erlang and that can process millions of simultaneous messages, and those are using millions of simultaneous Erlang processors. So we see Erlang being used in practice in server technologies across whole industry sectors. So it's a language which is usable in practice, it's scalable, it's robust. So that's some motivation. I mean, you've got your own motivation because you've got this far in the MOOC. What we'll do next is talk a bit more about the programming principles on which Erlang is built.